Hi, welcome to my channel. In this video, we want to solve the following problem. ABCD is a quadrilateral inscribed in a circle. The line segment BD is the diameter of the circle. And let E be the foot of the perpendicular from A to BC. We are also given that AB equals AD and AE equals 10 units. Let the area of ABCD be the area of the shaded region. Our goal is to find this area. And now for the solution. First, let's calculate the sides of ABCD, starting off with the length of AB and the length of AD. So, let's focus on the triangle ABD. Let R be the radius of the circle. Since BD is the diameter of the circle, its length is 2r. Next, consider angle DAB, which is an angle in a semicircle. Recall that an angle in a semicircle is a right angle. Therefore, angle DAB equals 90 degrees. Next, let's denote the lengths of AB and AD as L. Since triangle ABD is a right-angled triangle, we can use Pythagoras theorem to calculate L. We have L squared plus L squared equals 2r whole square. So 2L squared equals 4r squared. After dividing by 2 and taking the square root, we obtain L equals square root 2 times r. Next, let's calculate angle ABD, which is this angle. We shall make use of the fact that triangle ABD is an isosceles triangle. Recall that the base angles of an isosceles triangle are equal. Since angle ABD is a base angle, angle ABD equals 180 degrees minus 90 degrees divided by 2, which is 45 degrees. Following this, let's calculate the length of BC and the length of CD. So let's focus on triangle BCD. First, let's denote angle DBC, which is this angle, as theta. Next, consider angle BCD, which is another angle in a semicircle. Again, we use the property that an angle in a semicircle is a right angle. Therefore, angle BCD equals 90 degrees. Since triangle BCD is a right-angled triangle, sin theta equals the length of the opposite side, which is given by CD, divided by the hypotenuse, which is given by 2r. Therefore, CD equals 2r sin theta. Similarly, cosine theta equals the length of the adjacent side, which is given by BC, divided by the hypotenuse, which is given by 2r. Therefore, BC equals 2r cosine theta. Next, connect A to C. The area of ABCD is then given by the area of triangle ABC, which is this triangle, plus the area of triangle ACD, which is this triangle. First, let's calculate the area of triangle ABC. Recall that given a triangle with sides A and B and included angle gamma, the area of the triangle is half AB sine gamma. Since we know the sides of triangle ABC, all we need is the included angle, which is angle ABC. Since angle ABD is 45 degrees and angle DBC is theta, angle ABC which is the sum of these two angles, thus equals 45 degrees plus theta. Therefore, the area of triangle ABC is half times square root 2r times 2r cosine theta times sine of 45 degrees plus theta. 2 cancels out, so we get square root 2r squared times cosine theta times sine of 45 degrees plus theta. Let's expand sine of 45 degrees plus theta, giving us sine 45 degrees times cosine theta plus cosine 45 degrees times sine theta. Sine 45 degrees and cosine 45 degrees equals 1 over square root 2. Therefore, our expression becomes 1 over square root 2 cosine theta plus 1 over square root 2 sine theta, or 1 over square root 2 times cosine theta plus sine theta. Substituting this into our expression for the area, we observe that square root 2 cancels out, so we obtain r squared cosine theta times cosine theta plus sine theta. Next, let's calculate the area of triangle ACD. Again, we know the sides, namely DA and CD. So all we need is the included angle, which is angle CDA. Let's denote it as alpha. To calculate alpha, consider the quadrilateral ABCD. Angle ABC and alpha are opposite angles. Recall that opposite angles in a cyclic quadrilateral are supplementary, that is, they add to 180 degrees. Therefore, alpha plus 45 degrees plus theta equals 180 degrees. So alpha equals 135 degrees minus theta. Turning back to triangle ACD, the area of triangle ACD is then given by half times square root 2r times 2r sine theta times sine of 135 degrees minus theta. 2 cancels out, so we obtain square root 2r squared times sine theta times sine of 135 degrees minus theta. Let's expand sine of 135 degrees minus theta, giving us sine 135 degrees times cosine theta minus cosine 135 degrees times sine theta. Sine 135 degrees equals 1 over square root 2, and cosine 135 degrees equals minus 1 over square root 2. Therefore, our expression becomes 1 over square root 2 cosine theta plus 1 over square root 2 sine theta, or 1 over square root 2 times cosine theta plus sine theta. Substituting this into our expression for the area, we observe that square root 2 cancels out, so we obtain r squared sine theta times cosine theta plus sine theta. The area of ABCD, which is the sum of the area of the two triangles, thus equals r squared cosine theta times cosine theta plus sine theta plus r squared sine theta times cosine theta plus sine theta. Since cosine theta plus sine theta is common to both terms, the expression factorizes as r squared times cosine theta plus sine theta times cosine theta plus sine theta, or r squared times cosine theta plus sine theta whole square. To conclude, we need to find the value of r squared times cosine theta plus sine theta whole square. To do this, we focus on triangle ABE. Since triangle ABE is a right-angled triangle, sine of 45 degrees plus theta is given by the length of the opposite side, which is 10, divided by the hypotenuse, which is square root 2r. After writing sine of 45 degrees plus theta as 1 over square root 2 times cosine theta plus sine theta, we multiply both sides by square root 2r to obtain r times cosine theta plus sine theta equals 10. After squaring both sides, we obtain r squared times cosine theta plus sine theta whole square equals 100. Therefore, the area of ABCD is 100, which is the solution to our problem. As an exercise, try deriving the area of ABCD using Brahmagupta's formula and compare with the previous solution. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.